Okay, this video we're going to talk about the derivative of the function of exponent. This is also exponent a. All right. In the previous we talked about exponent, natural exponent e, right? The e. So now it's a. A is also a constant which is greater than 1, right? So, okay, what's the formula of differentiating this type of exponential function? So then you will have a to the power of x. Differentiate a power of x is just like differentiate e. You copy back, right? A power of x, and you're just putting a ln a, right? So you differentiate a power of x, and ln a. So secondly, so if you differentiate a to the power of fx, a function, any function, so it's same thing here. You copy back the a to the power of fx. First step, second step, differentiate the power, and add a ln a at the third step, the ln a of this number here. So what's the meaning here? I'm going to show you how to using this formula in differentiating this type of function. Alright, let's look at these two examples. So we have y equals to 3 to the power of x. So as I apply this formula, a is any number greater than 1. So a power of x. So I differentiate. So dy dx, very easy. Salin balik. 3. Your a is 3, right? So you put ln 3. Alright? So means that your answer will be constant. Ln 3 is a constant. Multiply with 3 to the power of x. That's all. Very simple. So let's look at this one. Dy dx. So also very simple. So you try to see 10 to the power of 2 plus 3x, right? So it belongs to this type where there is a constant. So this constant is a to the power of fx, okay? A to the power of fx. So a to the power of fx. So to differentiate this one, the first step here will be salin balik. Copy back this whole thing. Second step, differentiating the power. Differentiating to 0. Differentiate 3x. You have 3, right? Your second step. Third step is look at the number here, 10. So we're putting ln 10, right? Ln 10. So if I rearrange this whole thing, the dy dx will be 3 ln 10 is a constant. 3 ln 10, 3 ln 10, 10 to the power of 2 plus 3x. So this is the answer for these two question. Alright, it's the same thing. We are going to apply this formula because there is a function fx where this is a function with ln x and x, right? So easy, it's the same thing. Just need to apply the correct rule. So, okay, formula, so 2, salin balik, copy back this whole thing, and differentiating the power, right? Differentiating the power. So differentiating ln x, as you know that differentiating ln x is 1 over x, right? 1 over x. So differentiating negative x will be negative 1, right? And okay, if you're done with everything, then you look at the 2 here, then you put a ln 2. Okay, so if I rewrite, it will be ln 2, 1 over x minus 1, multiply with 2 ln x minus with x, right? So as simple as that. Alright, let's look at this. So it's same thing, but this is everything inside a power, right? Inside a power. So this one will apply power rule or chain rule. So very simple. You have to deal with the power first as everything inside a power, right? There are nothing beside. Everything is inside the power. So what we do is we bring down, we're differentiating, we bring down the 5, and as usual, we copy back this, right? Copy back this, and the 5 reduce power by 1 and differentiating the function inside, right? So, okay, be careful for this one. You have to apply the correct formula, which will be this formula, right? So you have to copy back 2x to the power of 2 and differentiating the power, right? Follow this formula. So you will have 2 to 4x, right? 2 to 4x. So, and don't forget to putting a ln 6, right? According to this one, you have to put with ln 6 and plus with differentiating e to the power of negative x. The technique will be e power of negative x. Do you still remember how to differentiate e to the power of negative x? You copy back, then you're differentiating the power. So then you're getting this, right? So rearranging everything, you will have 5. You have 5. This one you will have ln 6, 4 ln 6x, right? 4 ln 6 is a constant. 4 ln 6 is constant. X 6 2x to the power of 2 negative e to the power of negative x, right? And multiply with 6 2x to the power of 2 plus e to the power of negative x to the power of 4, right? 5 minus 1. So this will be your answer. So where I apply the chain rule. Right, let's look at this. This of course is not a single function. It's a single function but with a product, right? You see this is 2 to the power of fx, but you cannot differentiate as you have x here. So this one is a product, right? You multiply. So we're going to use the product rule. So product rule, your u and your v. You have to know your u and v. So your u is x and your v is 2e to the power of x, right? Okay, so we have differentiating the u, you're getting 1. Differentiate x, you're getting 1. So differentiating this one, this is the one that important here. So you have to salin balik, right? According to this, 2 to the power of fx. Then secondly, you differentiate the power, right? Differentiate the power, you know, differentiate exponent, you're getting back ex, right? And finally, you have ln a, right? Your a is 2, so you are putting ln 2. So you have done with all this, so you apply the product rule. Product rule will be u v prime plus with v u prime. So u, your u is x. V prime is ln 2 ex. Ex 2 e to the power of x, right? Then plus with v, your v will be 2e to the power of x, v u prime 1, right? So if you look at these two, they only have a common factor. This is the common factor here, so I can take it out if you want. So 2e to the power of x, then inside you will have ln 2 x ex plus with 1, right? So this is the answer for this question by applying product rule. Alright, that's all for this video. So I already teach you all the how to differentiating this type of function.